Okay, now section 8.2 talks about a technique called integration by parts. And this comes into play when you have a function that is two different functions multiplied together inside your integral. So a product, okay? So if you think about this, if you had one function and you multiply it times another function in here, okay? Two things that are multiplied together, that's the formula that we developed. Now, we already can deal with some products. We say integral of x dx, we would say, well, that's x squared over 2. We say the integral of x squared dx will be x cubed over 3. But notice it's not as simple as just saying, okay, if I want to do integral of x squared, I break it into the integral of x times the integral of x, because those two wouldn't match up. That square, or that times itself would not give you this. So this is specifically a polynomial case. In the case where we have two different functions here, we have to be aware of how we address it. And if we remember things about functions, one of the things we remember is we had something called the product rule before. And so if you have two functions, function u and v, both functions of x, and we have u, v, and we want to take a derivative of that. Now what do? Well, we say, well, derivative of that with respect to x. Hold the first, take the derivative of the second, plus hold the second, take the derivative of the first. Now thinking of this in terms of a fraction rather than a derivative, we look at dx here, dx here, dx here. If we multiply this whole thing by dx, it's going to effectively just wipe out all the denominators. And I'm going to have the differential of uv equals u times the differential of v plus v times the differential of u. Now if I integrate everywhere, and keep in mind, u and v are some function of x. I don't know what's going on with that. There's some function of x. But here, the differential of this whole thing is going to just give me uv. Over here, I'm going to have the integral u dv plus the integral v du. I don't know what to do with those because I don't know what u and v are. They could be anything. But I can rearrange this equation and ultimately get something that looks like this. And that piece right there is the formula for integration by parts. It comes directly out of the chain rule, working backwards, or not a chain rule, of the product rule, working backwards. And so I'm going to write that one up here because that is important. That's the one we're going to use when we have a case where we see two separate functions working up here. The derivative of one function and the other function just sitting there. Then this formula can be used to integrate this. Now, to get more specific, using some examples.